Hello, and welcome to another Light Reading Telecom Innovator video. This is Light Reading's sponsored interview series where we look at topics relevant to the communications sector overall, and we examine those through the lens of the people and the technologies that are moving the industry forward. My name is Phil Harvey. I'm an editor here at Light Reading, and today I'm joined by Roger Nichols from Keysight. Roger, thanks for joining me.
Thank you very much, Phil. It's a pleasure.
Absolutely a pleasure on this end as well. And we're going to be talking about 6G today. We're going to be talking about the state of 6G deployment and development. It's another generational change in the mobile technology landscape. And with each new mobile generation to date, we unlock several years of equipment spending, device updates, a refresh in services that tap into the network's leading edge capabilities. Of course, 6G is not what we're using now, so it makes sense to start this conversation by asking Roger, where are we in the 6G timeline now, and then what milestones are we looking forward to?
Well, I would put the position of the generation to be just entering that transition between where most of the work is research to over the course of the next, 18 months, it'll move to where most of the work is development. And the very first steps of standardization are underway. There's a workshop next month that the standards body 3GPP will hold to do the initial work on scoping for the initial releases.
Okay, so it's in process, in development, but very quickly kind of on its way to deployment, in a couple of years or so, or at least early deployment.
Well, I would say development. Deployment doesn't happen until the standard is complete, which would be, later in the decade.
Okay, good call there. And so we're gonna talk about like where we are on track to the completion of the standard. But in our reporting at Light Reading, we talk about all kinds of things that externalities that influence the development of new technologies. I'd like to run through three of them that could affect 6G's rollout and get you to weigh in on what's going on with each of them or what things we can kind of look out for. And so those three things they're pretty big topics too: spectrum, regulation, and geopolitics. We can take them in any order you want, and I'll prompt you when we to go. But I mean, maybe we could start with spectrum. Where what's the situation with 6G as it relates to the spectrum that's available?
Well, I just did a webinar on spectrum this week, but I think and I see that as probably one of the biggest regulatory activities, actually. So it's almost a combination of two of your topics. I think the general consensus is that spectrum is a risky area. There is a need for more, largely as viewed by the operators, for the sake of growing capacity and potentially moving to higher data rates. But it's really a capacity issue when you look at the consumption of data around the world and how that is growing. There are some fierce arguments about whether the mobile wireless industry needs more spectrum or not, and it depends on who you talk to. But the policymakers are paying close attention, and some of that work is underway with some of the work last year by the ITU and what many of the national bodies are looking at. So spectrum is kind of a big deal. Obviously, for new spectrum, the most watched area is that territory between 7 and 24 gigahertz, with more focus on the lower half of that.
Yeah, and the characteristics of that set of that spectrum band, those spectrum bands, what makes them special that relates to 6G, or what's the sort of how does that sort of unlock 6G's potential?
Well, the view of that is as for adding more for the sake of use in commercial mobile wireless. So part of it is that there are larger bands available for contiguous spectrum because it's a larger frequency band. Um, and that is desirable by the operators because they need significant exclusive use of large bands of spectrum for the sake of managing customer uh, satisfaction.
Okay.
And the challenge is that most of that spectrum is already used by governments, by military, by satellite, radio navigation, radio location systems. And so addressing coexistence and moving incumbency is a pretty serious policy issue pretty much everywhere on the world. But and then the focus on the lower half of it is because the physics of the lower frequencies, the ones that are a little bit closer to what we're more familiar with in mobile wireless, which right now peaks out around 4 gigahertz, it's just easier to manage, a little bit less exotic componentry and designs. Although it's not without its challenges, it's certainly easier to manage than some of the bands that are much higher up, like those introduced in 5G between 24 and 52 gigahertz.
Okay, that makes sense. Like you said, spectrum and regulation kind of go hand in hand. Let's quickly touch on geopolitics. The one thing everybody agrees on is that we do need a new or continually need to refresh generations of mobile technology and move towards 6G. But there's disagreements as to, I guess, whose technology is going to be dominant or what standard process is going to be dominant, I guess. How would you kind of summarize the geopolitical risks of 6G?
Well, I would say that every sovereign nation wants to contribute in a way that is to their benefit in terms of developing technology that helps their nation benefit from a business perspective for the investments. And so there's a lot of national politics that have moved investment to earmarked for technology in the next generation of wireless or the evolution of wireless. That becomes manifest amongst the bigger nations of something a little bit more of a serious competition. When you weave that in with the larger geopolitical mixture, then in some cases there appears to be words of maybe having standards that are that could be country specific or region specific. Now that's a fear that the industry has because if you have unique standards, you lose the economy of scale without having a global investment in the same area. And everybody I've spoken to, regardless of what country they're from, does not want a bifurcated standard. And I actually don't think that will happen just because the industry does recognize how expensive that will be for the sake of what's going on. So I think what we're going to be more likely to see is how governments are helping their home industries contribute, have access, or create and own the intellectual property for standards, essential patents, and that kind of thing. And that's always a little bit of a competitive jockeying that goes on. And my hope is that stays to be a healthy tension. At least in the technology world, I think that's an important thing for the sake of our business and really doing what is going to benefit society the most in terms of evolving to the next generation.
Do you think we're still on track for the completion of a standard by 2029?
Well, it's tough to say, but one of the things that has been discussed openly in the industry and in 3GPP is looking back on some of what we can do better in the next phase than what we did in the early phases of 5G, and that would be to not rush the standard to completion. I think that was seen as something that presented some of the challenges that even 5G is currently facing, and so the statement from 3GPP is that release 21, which is, right now they're going to start working on the scoping of release 20. So we're still a ways away from this, but release 21, which will be the first implementable version of 6G, will be complete no earlier than March of 2029. And it's interesting they've made that statement no earlier than, which means they haven't set a deadline for when to finish. they've actually set a deadline for when to start, which to me is a positive move because then it doesn't pressure for. I mean, there's enough pressure anyway in the industry, but it won't pressure for that sort of early release.
Yeah, that's a good point. I agree. That is definitely a positive step in terms of how they're setting up the work and the expectations that follow.
Yeah.
Okay, now another sort of group of three. I want to quiz you about three technologies and how these main technology areas are either enabled by 6G or can kind of coincide to enhance 6G. The first one is AI, because we can't have any discussion about anything anymore without talking about AI. But 6G does have quite a lot of relevance to AI. So how do those two technologies sort of enable one another in your mind?
Well, the first thing I'd say is that I see the link between 6G and AI as something that's a little bit different maybe than the rest of the world thinks about when you think AI. A lot of the press is around large language models and how they're evolving. And while that will be used maybe by people using 6G, I think the point of using AI as a native enabling technology in 6G has more to do with models that facilitate the network to overcome some of the challenges of complexity, some of the challenges placed by physics and that sort of thing. So large language models are trained on humans' language response, but the AI that will be used to enable 6G will have more to do with addressing the complexities of, in the early case they're working on now is radio beam management, location, precision, channel state information, that kind of thing. But that will evolve to using AI to help even design the systems potentially, also to optimize traffic flow, maybe even to optimize power consumption, and it really help facilitate the moving of all the levers to control a network, which have become very complex. Things that go kind of beyond what a single human operator could do. And some of it's going to work really well, and other things may not work as well. And that's some of the development that's going on right now. But they've been talking about making AI sort of fundamental and native in 6G as an enabling technology since the very beginning of the discussions, back in the last decade, in the late, in like 2018, 19, when these discussions started.
Yeah, exactly. We were talking about it as machine learning, but it kind of evolves on the same track.
Yep. As machine learning being one type of AI, and that's really where the focus is.
Yeah, that kind of high speed pattern matching, and also being able to spot things like network anomalies in a way that humans simply can't manage with so many devices connected.
Yeah.
The next two are kind of interrelated, or could be. So we've got Open RAN, for the radio access network, and then we've also got like a very specific piece of that, which is next gen MIMO or multiple input, multiple output antennas. How does 6G sort of what bearing do those two technologies have on 6G?
Well, so the concept of Open RAN really started in the early development of 5G. And the idea is to enable virtualization of as much of the RAN as possible. So the RAN is the radio access network, the base stations, right? But there's still a lot of digital processing that happens. And so as much of that can be virtualized and thus put in the functions and software entities helps make the network more flexible. But when you start virtualizing these things, you have to standardize on the architecture of where you divide the pieces of the radio access network, which used to be sort of a proprietary link. If you think about the base station or the G node B, that was a black box, shall we say, in previous generations. And in 5G, the work was done to split that apart. But you have to have the industry agree on the architectural segmentations. And then the concept of Open RAN is to define standard interfaces between those as you disaggregate the G node B and make those interfaces open, hence the name. So that will continue in the 6G space. I think the days of purely proprietary links between the core all the way through to the antenna are moving to an end. That's a frustrating part for some parts of the industry, but maybe others it's seen as necessary. Um, and a critical phase of that will be how that evolves from 5G into 6G. And some of that work is now being discussed even within 3GPP, which up until, a year or two ago was not spending a lot of time on that concept. Um, the next generation of MIMO, so, MIMO was really about taking advantage of what we used to not like about radio, which is multipath interference. And the where MIMO has really helped in the last generation is in improving the link at higher frequencies, improving the capacity and the link budget at higher frequencies. So 3.5 gigahertz was pretty problematic. And then they used more complex and sophisticated antenna schemes in MIMO to really improve some big gaps they had in the uplink budget from the phone to the base station. That's going to continue. We're going to move up to even higher frequencies if we are successful in managing the policy changes and incumbency changes for this 7 to 24 gigahertz area or somewhere within there. Those are even higher frequencies that have even larger link challenges. And nobody wants to decrease the cell size anymore because it's too expensive. And therefore, I think further advancements in MIMO are going to be necessary to ensure that those links are maintain the quality that we're used to, and even to drive some of the flexibility of the use case. Like MIMO can actually enable some devices to have far more, data capacity and other ones not. And in any given network, that's okay, because if you can manage that, then you're optimizing your use of network resources. So those will both continue to evolve for the sake of 6G for those, and I'm sure several more reasons.
Yeah, that makes sense. Let's get into some of the, one of the more, I guess, popular talking points of 6G in general is the initial use cases, and what we're sort of looking forward to this technology unlocking for either businesses or consumers. What are some of the ones that you're, focused on hearing about or kind of planning for, in the short term?
This is also a point of contention in the industry. There have been a lot of discussions on this. The very first 3GPP workshop, which was last May, if memory serves, was focused exclusively on use cases. And if I knew the answer to your question, then I would be investing money in where I thought that was going to come from. There is a lot of speculation on this, but I will say from a practical standpoint, it really comes down to two things. First of all, every time there's a new generation release, the initial use cases are what the industry is used to because it's easy, right? We got a brand new technology. There's a lot of wrinkles you have to work out of it. And so you implement what people are going to expect and leverage the new capabilities to make improvements in those use cases in small steps. But I think the vision for 5G, which many claim has not been realized, and I would say that to a large extent is because of the slow adoption of standalone networks, because 5G really isn't 5G without standalone networks, meaning the flexible network that is truly programmable. By the time 6G rolls around, the concept of SA in terms of deployment and working out what it can and can't do will be much more mature. And that is what will enable use cases that go beyond the standard use cases we have today, which are dominated by entertainment and advertising. And that is what we would look forward to, I believe. And that means helping out with logistics. We're already seeing some of that. There's some industrial applications where the systems end up being more reliable. Talked to a concrete manufacturer a few weeks ago that said their 5G system was more reliable than their 4G system. That sort of thing. So I think the other industries that traditionally don't use mobile wireless will start in to use this capability because of improvements in reliability, uptime, and to some extent, certain performance. And the last thing, there is, entertainment and advertising are not going to go away, right? That's going to change in face. And my guess is that the advent of extended reality capabilities, whether that's in headsets or other kinds of devices, not just smartphones and that kind of thing, is going to change the face of how that is used. And the flexibility of the network that you can expect from the new generation is what will enable sort of a new focus on how that's going to work. So those are my speculations, but way back in the 3G days, I was looking at cell phones that had cameras on them, and I thought that was a really dumb idea. So I'm the wrong guy to ask about the future.
Well, it didn't really take off, but we'll keep looking forward to those cameras on cell phones. We'll see if it ever shows up. Actually, it's interesting too, because you're right. We are kind of geared to think about what we're familiar with, because the advent of camera technology itself, took leaps and bounds while the network was evolving. And so when those two things marry, so that's what I'm looking forward to, especially in the, I'll call it augmented reality, but, extra reality space, is being able to gain a deeper appreciation for things like, history, geography, city tours and things like that, that kind of can make, especially those of us that are visually driven, can kind of make these dry topics really stand out. Absolutely. At the moment that you're either occupying the space or near enough to it.
Education, training, troubleshooting, all of those things will take on a different light and could be pretty useful.
I think that's something that I'm excited for. I can't wait for it to get here, but I have no idea what it looks like yet. So that's to your point. Some of this is going to be a little bit of a leap of faith. So to wrap up, let's talk about Keysight's role in 6G development. So what is Keysight working on doing, whether it's on the education side, the testing side? How are you directly involved in the development of 6G?
Well, I think folks know that Keysight is, we make measurement and design solutions. And what that means is that we don't actually design the radios or the networks or the Kubernetes or even the AI systems that will be used in these networks. Our job is to enable that by providing design aids, making physical measurements, helping folks with functional measurements, even end-to-end assessment, to enable them to know how well their designs are working and continue to optimize those. So, what is our engagement? Well, we're engaged with many entities around the world, from academics to government labs to bilateral engagements or even consortium engagements in the commercial space. And you have to do that early on. And that is, there's collaborations we have going on around the world. Some are public and some are confidential, that are along the lines of moving that technology forward. The other angle on this is that if you think about wireless, it's every discipline in electrical engineering plus a lot of disciplines that are outside of electrical engineering. And so the breadth of our portfolio enables us to engage in most of those, including, everywhere from semiconductors and physics to Open RAN systems, and even to the development, testing, evaluation of AI, whether that's helping folks with the data or their model development or their model validation. And that starts with research and goes all the way through to deployment. And that is obviously in all those different entities. And so that's what we're pretty excited about as a kind of an enabler in this space. And then the big other thing I would add to that is, I pushed very hard for this in the 5G space. It's something we've done for a long time pretty well, but to do this in the context of what the people inventing these systems are doing, speaking their language in that space. So really, we all have a lot of fancy electronic toys, and a lot of times we learn about a capability that toy has years after we start using it. And we don't want that, right? We want people to take full advantage of what they have in their hands as quick as possible. And so understanding how it's going to be used and how best to leverage the capabilities we put in these solutions is another piece of it, and that is the expertise that we bring to the picture as well. So it's all those pieces, and to me, that's what's exciting is the breadth of being involved in all these technologies.
Yeah, absolutely. Thanks for the kind of the overview there. Also, unsolicited, I'll plug the 6G spectrum landscape white paper on your site. I found that to be incredibly helpful as we were coming up to speed on where these particular spectrum concerns are. So we're just about out of time. Obviously, you can go to keysight.com and find out more about what Roger was just talking about, and dig in a bit more about the company sponsoring this particular video and audio series. Also, if you're hearing this podcast series or video series for the first time, please go and check this and past episodes out at lightreading.com. Roger, thank you so much for being my guest today, and everybody, thanks for listening.
Thank you, Phil. Cheers.